Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors Chapter 12 Quiz Review Solutions on Matrices. For this first problem, they want us to do the indicated operation, which in this case is subtracting the matrices. Since these matrices are the same dimensions, we can add or subtract them just fine. All we have to do is just subtract the numbers that are in the same position in this order. So we're going to have -9 minus -3, so plus 3, and then -9 plus 7, or actually 3 plus 7, same position, and then 5 plus 8, 1 minus 2, 3 minus -4, so plus 4, and then -8 minus 9. Now just crunch the numbers here, so we've got -6, 10, 13, -1, 7, and -17. To multiply these matrices, let's first check to see if they're compatible. So the dimensions of the first one, we've got a 3-row by 2-column. The second one is a 2 by 2. Because the columns in the first and the rows in the second are the same, they're both 2 in this case, that means we can multiply these out. And then the dimensions of the new matrix will be the number of rows in the first and the columns in the second. So we're expecting a 3 by 2, just like this first one. All right, so let's multiply them now. To multiply these, we basically dot multiply each row in the first matrix by each column in the second. And then we put the result in the position that has the same row and column. So we're going to be doing 3 times -4 plus -6 times 9. And since that was row 1, column 1, that's going to go in row 1, column 1 of the new matrix. Next, we have 3 times 5 and -6 times -3. Now on to the second row, 7 times -4 and 0 times 9. And then 7 times 5 plus 0 times -3. And then finally, the last row, -1 times -4, 2 times 9, and then -1 times 5, and we'll add that to 2 times -3. All that remains is to simplify each of these. So this is -12 minus 54, so -66, and then we have 15 plus 18, so 33. This is -28 plus 0, so -28. 35 plus 0 is 35. This is 4 plus 18, so 22. And finally, -1 minus 6 gives us -11. To find the determinant of a 3 by 3 matrix, we have to first copy the first 2 columns over here to the right. So 6, -7, -1, and -1, 5, -1. Those are just a direct copy. And what we're going to do next is we're going to multiply the diagonals going down and add all those together. And then we're going to multiply the diagonals going bottom up. And then we're going to add those together, and we'll subtract what we get for those 2 different sums of products. So let's take this one step at a time. Starting up here, we're doing this first downward diagonal. So that's 6 times 5 times 6. That's 30 times 6, which is going to be 180. And then for our next diagonal, -1 times 2 times -1, that's going to be a plus +2. And our last diagonal going down, we've got -8 times -7 is 56, times -1 is -56. All right, so next up we're going to do these upward diagonals, and we're going to subtract all of those together. So I'm going to do a minus parentheses for the first product here. So we've got -1, 5, and -8. That's going to be +40, but we're subtracting that inside of parentheses. And to that, we're going to be adding -1 times 2 times 6, so -12. And this last diagonal, 6 times -7 times -1, that's going to be a +42, being subtracted in here. All right, let's see here. I'm going to just use Desmos to crunch these numbers so I don't mess it up. So we have 180 plus 2 minus 56 minus parentheses 40 minus 12 plus 42 all comes out to 56. To find the inverse of this 2 by 2 matrix, I can use my inverse formula. That's 1 over, AD minus CB, so basically 1 over the determinant. And then inside we're going to be switching the A and the D and negating the B and the C. So let's do 1 over our determinant. That's going to be 1 over -7 minus -6, so plus 6. And inside the matrix, we're going to be switching the top left and bottom right. So -7's up here, -1 is down there. And then we negate the bottom left and upper right. So we have -2 and +3 in those positions. All right, so now we simplify this. This is -1 down here. 1 over -1 is -1 overall. So we're just doing -1 multiplied by this whole matrix. So each of these just gets multiplied individually by -1. This is going to be a -7, -3, +2, and +1. For this problem, they're asking us to use matrices to solve this system. We could do it without matrices, but here's some matrix approaches. There's actually several. I'm just going to show you determinants on this slide, and on the next slide, if you want to see the inverse approach, I'll show you that as well. So for determinants, we essentially have to set up and take the determinants of 3 matrices. One of them, the first one, which I'm going to call A, is going to have the coefficients in it. So that's going to be -2, 1, -6, and -1. And I'll just take these determinants as I go. So this is going to be 2 minus -6, so 2 plus 6, or 8. Now my next matrix, which I'm going to call B, is going to basically be the A matrix, but I'm going to replace the X column here with the constants column. So I'm going to still have the 1 and the -1, but now instead of -2 and -6, I'm going to have the -3 and the 3 from the constants side of the equation. But I'll still take the determinant. So this is going to be 3 minus 3 going each way. That comes out to 0. And then finally we'll do matrix C, which is going to be matrix A again, but this time instead of the Y column, I'm going to substitute that out for the -3 and the 3. So -2 and -6 are still there, and now the constants go in the Y column instead. So the determinant for this one, we've got -6, and then this is going to be minus 18, so grand total of -24. Now to find the X value here, I have to do determinant of B over determinant of A. And this is using Cramer's rule, by the way, Cramer's rule with determinants. So this is going to be 0 over 8, which comes out to 0. And then for the Y value, we need determinant of C over determinant of A. So -24 over 8, which is -3. So 0, -3 is our final answer for this one. So hopefully you liked the Cramer's rule approach to solving the system. I'm going to show you one using inverses now. To use the inverse to solve this, we're going to set up a matrix equation that has a matrix for the coefficients, a matrix for the constants, and we'll have a little random X matrix in there that will be our solutions. So I've got -2, 1, -6, and -1 for my coefficient matrix, just like I had with the Cramer's rule approach. And I'll have an X here to represent the solutions, and that's all going to equal a little matrix with the constants in it, -3 and 3. So to get this process rolling, I have to take the inverse of my coefficient matrix. So we have 1 over the determinant of that. That's going to be 1 over 2 minus -6, so 2 plus 6. And in the matrix itself, I'm going to switch the A and the D, so we'll have a -1 and a -2 in that order. And the B and the C get negated, so -1 and +6. And I'm going to multiply this 1 over 8 by each of these things and multiply that inverse by each side of this matrix equation. So here was the coefficient from the left side of the matrix equation, and we've got 1/8 times -1, which is -1/8. And we do that again for this -1. That's also -1/8. 1/8 times 6, 6 over 8, we can reduce that to 3/4. And finally, -2 times 1/8 is negative 1 over 4. So this whole inverse matrix gets multiplied now on the left side of this next matrix on the right. And I'm going to go ahead and actually do a little matrix multiplication with the calculator, not the matrix calculator. I don't need that one for this. But I am going to use my Desmos scientific calculator for some number crunching. All right, so let me do each row of my inverse matrix times the constant matrix columns here. So we've got negative 1 over 8 times negative 3 minus 1 over 8 times 3, and that comes out to, believe it or not, exactly 0. Cool. Now I'm going to do the second row times the negative 3 and the 3. So I'm just going to change the first numbers in this multiplication, the fractions here. So we've got 3 over 4 instead of negative 1/8 there, and I have negative 1 over 4 here instead of negative 1/8, and that result is going to be negative 3. So we end up with the solution, just like with the Cramer's rule approach, of 0, negative 3. Just another way of doing it.